Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. This is tutorial for statics for chapter 2, the part where we deal with 2D problem, right? So this is the early part of chapter 2 before we go to 3D problems, and then position vector, unit vector, force vector, dot product, etc., right? So this is the foundation of it all, basically how to compute using vector analysis, starting from 2D. Now, bear in mind, in 2D problem, we can actually just use scalar analysis, and we will show both analysis in the tutorial. But why we are learning about vector analysis? Because we want to use it again and again in 3D problem, most of the case, right? So in 3D problems, we will talk about it in the next chapter or next topic. It will be, or most of the time, it will be very difficult if you want to solve using scalar analysis. So we will use vector analysis. Hence, to understand the method, we start with 2D to make it easy for all the students to understand what is going on first before we go to 3D and much more complex problem, right? So understand the context of why we are learning this, right? It's not purely just to solve 2D problem. It is to understand how we apply the method. All right. So in this tutorial videos, the questions I take from the previous exam questions, right? All the questions from the past. I see if the question involve the topic that we are covering, it will be covered in that particular tutorial video. All right. So for this particular tutorial, we will look at the midterm, pass all the midterm exam, and see if there is any 2D problem for vector, right? The PDF can be found in the description box below. You can download the PDF, see the questions, and then we'll discuss on how the solution would look like, right? Okay, so that's number one. Number two, for every tutorial videos, do take a look at the comment section, because some of the videos that I have recorded may contain some mistake, because most of the time I do not have the time to actually solve the question first and then just copy it for the tutorial. It's most of the time I'm solving it while I'm recording, right? So sometimes mistakes happen, so some of the students may observe it, comment in the comment section, and I will verify whether that is a mistake, etc. So just to take a look if anyone actually from the past already pinpoint any mistake, if any. Hopefully there's not much, but it tend to happen that I'm a human, I make mistakes, right? So with that said, let's go for this tutorial session, which is involving 2D vector problem. Okay, if you look at the side there, I'll try to put the diagram on that side. We have the structure there. We have two forces, F1 and F2. The value is given, 30 kilonewton and 20 kilonewton. The angle is given, and we need to determine the resultant force, F1 and F2, as a magnitude as well as Cartesian vector. So in this question, it actually asks for both. What is the resultant in terms of magnitude as well in terms of Cartesian vector form, right? Right, so let's solve. So of course, as I mentioned, there are two possible ways to solve any question, which is scalar or vector analysis, right? So let's try to use scalar first, right? So in scalar we'll just have to take note of the x component and y component, right? And then get the summation of fx and fy, and then get the resultant, right? So in this case, so hopefully you can refer to the PDF as well as the diagram here, right, for the question. So if you do summation of fx, hopefully this color is clear. Maybe I'll try to use a different color. So if you do summation of fx, taking to the right as positive, so for F1 we have 30 sine 30 degrees to the positive, right? And then for F2 we have 20 to the negative side, so minus 20. So if you calculate this one, you should get minus 5 kilonewton, right? This minus meaning that it is in the direction towards the left. Hopefully this you can see, right? Can you see? Hopefully the glaring of the light is not affecting. Right, and then if you do summation of Fy, okay, the marker is no longer. So let's try this one. So for F1 we have downwards, so minus 30 cos 30 degrees, and then for that F2 it doesn't have any Y component force, so we'll have that one. So basically you get minus 25.98 kilonewton, right? So what this means is the resultant have X component to the left for 5 kilonewton value, and have the component, because this is downward, right? So have the component of force downwards for 25.98 kilonewton value, right? So the resultant will be here, and the angle there, right? So if you calculate this one, you will get the resultant. Of course, you should know already how to get the resultant. Fr using the, so 5 square plus this one 25.98 square, you should get an answer of 26.5 kilonewton. So here is 26.5 kilonewton, right? And the angle, if you calculate, you will get 79.1 degrees. Hopefully you know how to calculate this, or if you need to, theta equal to, of course you need to show, right? Because you need to specify the magnitude is in which quadrant, right? So tangent -1, so 26.5 over 5, and then you get 79.1 degrees. So in terms of magnitude, this is the magnitude. Of course you have to supply with this information and this information as well, for it to be a complete answer, right? Because we have to specify the direction and the magnitude and the direction, right? We deal with vector here, it has to have both information. And when we say theta, it should be clear where the theta lies, right? So either you draw like this, or sometimes you have something like this, right, in the book, to indicate that that is the quadrant, the theta is where it is. Okay, so that is scalar analysis. Of course, the question asks also for Cartesian vector notation. Right, if you are using scalar analysis until here, until this point actually, from here you know already what is in the Cartesian vector form of the resultant, right? Fr. So you already know X component, Y component. So what you will have is just minus Fi, and then minus 25.98 J kilonewton. Of course, the unit must be there for a complete answer as well, right? So that will be your answer, right? So this is the magnitude, and this is the Cartesian vector resultant. This is if you do in a scalar analysis. This is scalar analysis. What if you want to start from the beginning with a vector analysis, right? So I leave the answer here. If you start from the beginning with a vector, so you will normally specify or express each force in Cartesian vector form. So for example, F1 in vector. Is there any glaring? Hopefully not. So for F1, you will have X component is 30 sine 30 I, right? And then minus 30 cos 30 degrees J. Okay, so F1 vector will be basically you will get 15I minus 25.98 J. That is the force in Cartesian vector form for F1. For F2, you'll have minus 20I plus 0J, right? It doesn't have any Y component, so basically that's it. So Fr, what you do is it's just simply F1 plus F2, right? So basically you just add this component and add meaning add the x component and add the y component, right? You add this and you add, oh sorry, you add this, right? So 15 minus 20, you get minus 5. So it's going to be this answer back again, right? So minus 5i minus 25.98 J kilonewton. So that will be your answer of the Cartesian vector form of the resultant force if you use vector analysis. Of course, if you use vector analysis, you will reach this answer first, and then because the question actually asks as well for the magnitude, right? So to complete the answer from the vector, you have to know how to get the magnitude, right? So to get the magnitude, so when you get this one, so FR magnitude is simply just square root of 5 square plus 25.98 square. So you'll get, what was it, 26.5, right? And then you have to get the theta for the tangent minus 1. Okay, this one from that understanding, right? So we are calculating this theta, and we have shown just now, right? So you know the answer already. So I'm just showing how to solve it using scalar analysis in the first place and then vector analysis here, right? You can use both if you have question like this. Any which way will give you the same answer, right? It's just different way of solving. The answer is the same. However, you really have to understand the vector analysis because when you do 3D, normally we will use vector analysis, right? So that's why we learn in the first place. So make sure you understand how to express each forces in Cartesian vector form and what to do next, right? So for 2D vector, that is it basically. This is the only question that I can find of 2D in this nature, because there are other 2D problem as well in chapter 2, but later on, right? When we have the other part, right? But for just getting the resultant vector, that's the only question that we have. So the video will end here, inshallah. So we will see you next in the next video, next tutorial, where we deal with a 3D vector, inshallah, right? So if you have any question, any comments, feel free to comment down below, give the question, and inshallah we will discuss based on that, right? Wallahu alam. So for this particular tutorial, this is the end. Thank you, hopefully it helps. Wallahu alam. Assalamu alaikum warahmatullahi wabarakatuh.